Here's where things get tricky. I try to keep it, well, I try to not confuse you. I'll do my best. But this is very unique to C++ and C, to be honest with you. And that is with parameters. But in parameters, I can give you a copy or the original. So think about it. If I were to give you a copy of the gradebook, if you made any edits to the copy, hey, your edits are good for you, but I still have the original. Nothing changed on the original. Now, why would you want to do that? There's actually a lot of, applications for just sending in copies. There's also a lot of applications, if you were a TA of mine, of me sending you the original so that you would be able to go ahead and make changes to the original gradebook. So both have their merits on exactly how you want to do it. Now, here's the interesting part. How do I know which ones I'm giving you, the copy or the original? Of all things, you're going to see an ampersand. And an ampersand you may have seen before from when we talked about pointers. If we haven't talked about it, we're really about to after this. Ampersand, the physical ampersand in a code, which by the way is not in this one, it's on the next example, will allow us to say, look, I am giving you direct access to the real value that is, the real value. If it doesn't have the ampersand, like as in this example that we have here with A and B, I am passing you a copy. You can do whatever the heck you want with that copy, but the original, original still will not be untouched. Now, without giving the ampersands, we're going to give copies. So if I had two values of Ravens and Pittsburgh, I'm a football fan, I'm from the Northeast, and I pass them over to that function of swapping the two values, the function's going to do its job. The function is going to swap the two values. The bad part is it's just swapping copies. Did I physically really change the Ravens or the Pittsburgh score? Nope, because I sent, make sure I get the right one, copies. I really don't care what happens with the copies. Now, did the copies change within this function? The answer is yes. But as soon as that function's done, my original two variables that came from somewhere else, they didn't change at all. That's the important part. Here's almost the exact same code. The only difference is literally in C++ is the ampersand. And notice, by the way, the ampersand's not over here. It's in the name of the function. The function's telling us, hey, I want direct access to both Ravens and this time the Redskins. I can't stand that team, which is not even called the Redskins anymore. But anyway, so I am going to go ahead and pass those two values, but not just pass those two values. I am giving the originals to those two values. So if this function is going to swap the two values, then it really is swapping the two values because I gave the originals. So when I come back here, the values of those two values did change and stuck. It did change, and the new values are stuck with one another being swapped. So that's a difference. Literally, that's the only difference between when it comes to logistically and code-wise of receiving copies or of direct access to a value. There's a lot going on here. But your questions are really down here. And by the way, it's the same questions for the function temporary swap and permanent swap. I would rather have you read through this. This is the same code, basically what I just showed you before. And just read through it and go from there first. Then you're going to answer the questions. What is the return type of the function? Temporary swap and permanent swap. What are the local variables to both of them? And then this last, what value would A be at first in either temporary swap or permanent swap? So again, that's the A, and then you see it there. There's the A. You need to tell me what the value is going to be originally. And the same thing for B. So let's start off with that first, and then we'll dive deeper into this hole we have in C++ and passing parameters. All right, number one, what is the return type of the function temporary swap? Well, let's go to temporary swap, and it's a void. How about permanent swap? It's also a void. So the functions themselves are not returning anything new to our application. Number two, are any local variables present in temporary swap? To be honest with you, that's actually kind of a trick question. Temporary swap, yeah, A and B are local variables. They are local variables, and so is temp. So there's actually 3 variables in that one. And for permanent swap, it's the same idea. We talked about this in functions 1, I believe, where you're passing in a parameter, it's actually local to that function as well. Now, how local depends on if it's got the ampersands on them. That means it's local to this function, we have access to it, but it changes the actual, well, it has repercussions for that variable that was originally called. Now for number 3, and to be honest with you, I'm going to answer both of them at the same time, 3 and 4. For temporary swap, let's go through this. So I'm worried about what A and B are going to be when I first call temporary swap. So that we have to go to the function that calls temporary swap, which is at the very top. So I'm going to pass in Ravens and Pittsburgh. Ravens is 0 and Pittsburgh is 14. So that's the 2 values I'm going to be putting in for a temporary swap. Respectfully, is going to be 0 and 14. Now, for temporary swap, for permanent swap, what are the values going to be? Well, I need to go to permanent swap. Ravens, I already decided that was 0, and then Redskins, that's going to be 34. Again, the order matters, and how many are there also matters. So as I move down to permanent swap, I'm going to be not just passing in 0 and, Redskins were 34. That's the values. But I'm also going to be I'm going to have access to those variables of Ravens and Redskins, so I can end up changing the values that are in them. So heads up when it comes to that. So that's your answer for this particular exercise.